Another method for measuring flowability is angle of repose. Here the advantage is you can get the information in a single measurement. We'll be measuring the angle the material forms on a fall. So this is an empirical measurement, so the distances and diameters are important, but you can get very excellent comparable data between materials with different flow characteristics. So now I'm going to let it flow. And you can see a nice cone with this well-flowing material. And then I simply measure how tall the cone is, 21.5 millimeters. So now we can calculate the angle. You can imagine that water flowing very well will be flat, and materials that flow more poorly will be more pointed. So this angle can be correlated to flowability. And let the powder fall. Now in this case, I'm actually going to stir it to ensure that the powder can make as big of a cone as it can. All right, now I'm expecting a much higher angle, 25.6 millimeters. So indeed, a higher angle for this less flowable powder. And here we have a measurement of only 18.8 millimeters, which corresponds to an angle of 32 degrees. Earlier we tested angle of repose for ProSolve SMCC 50. Now we're going to check the 90 grade, which has a larger particle size but is otherwise the same material. The reading's 20.9 millimeters. That corresponds to an angle of approximately 35 degrees. And now we'll take a look at a powder that is typically used for granulation rather than direct compression, and so is known to be less flowable, but is good for mixing with the API to make larger granules. And even here you can see on the spoon that it's a much less flowing powder. So again, I'll fill it, and I'll have my spatula ready. And now I'm going to drop it. And you can see it looks actually a lot like flour that you might bake with. And while I can stir it and get it through the holes, it's really not flowing on its own. All right, so the height is 32.4 millimeters, and that corresponds to an angle of about 47 degrees. Now that we have our angles, let's check the pharmacopoeia and see how they look. So here we can see that two of our values, 36 degrees and 40 degrees, are at either end of the fair range, whereas the 47 degrees we got for the last sample has poor flow, requiring agitation or vibration for flow to happen, which is indeed what we saw in the angle of repose. Another way to evaluate flowability is actually the Hausner ratio, looking at the ratio of tap density to bulk density. And if we check on the next page, we'll see that actually it has the same ratings for flow with values for Hausner ratio. Let's talk a little bit about bulk density and tap density and how they relate to this ratio.
In the next episode of JRS Tableting Studio, we continue our flowability series by exploring how powder flow can be quantified using density measurements. Learn the difference between bulk density and tap density, how the Hausner ratio is calculated, and how these values are classified according to pharmacopoeial standards. JRS Tableting Studio. Stay tuned.